probably you can also not create a folder, just put. And I would like to put a new file, so we can start the new file. And the new file, the name, I don't know, the first one was called test0, probably we can say test1, but it is up to you. It is every name, it is good. You need to do .py at the end, because otherwise so this is not a new directory, this is new file, the same directory, new file, the area. I have tried to enlarge the thing as much as possible. For me, it will create some confusion, but please let me know if you cannot read this. I will just start importing NumPy that we have already imported yesterday in order to do some calculation and also the array. So import NumPy as NP. We can always save our changes here, so you save, so you have all the things. Obviously, he complaining, NumPy is imported but not used. Okay, we have not done nothing, so we need to implement here an algorithm that solves the equation, so on. So I will use fsolve. Fsolve is a solver of available in NumPy, in Python, in NumPy, that is able to solve the equations, also nonlinear equations. So it is quite generic. In order to include this, I will click here, and it says from scipy.optimize import fsolve. So you see that we are using another library. It is the scientific library, so it is called scipy, and this sub-library, it is optimized. And from this library, we took this solver, fsolve. So this is a function that is able to solve some equation, also a system of equation. I save, and hopefully it doesn't give any error. In general, scipy is already installed. Do you have any error so far? Any question? No. So I will just keep just put as a comment the instruction in order to use fsolve. So we are able not to write the rest of our script in order to use fsolve. So I will put just a comment as a comment here, and so I'm starting with this symbol, that means a comment for Python, and write solution. We hope that we found a solution, or today or next, and then fsolve solve. And then inside we need to say to solve what to solve. So we need a function that I can call equation. You can call it. So we need to create this function, the function that contains our equation. And then we need the initial guess of the solution. And probably in this function of the equations, we need some parameters. So these parameters are grouped in the args, so in the arguments of the function. So are the inputs of the equations that we need to solve. And we will see what are these. So this is the structure. Do you have any question? No. So we try to use this fsolve. At the beginning, I would try to create the objects. I mean, you can solve this problem in a very simple way. I mean, but since yesterday we talked about objects, and the objects are the characteristic of Python, no? So we can try to create not the car, the object of yesterday, but the line, the branches, and the nodes. So in order to create the objects, we can recall, we will use after this equation, we can recall that in order to create an object, we needed to start with class. Is it visible, class there? So we can give a name of these objects, and I put a name that is called branch. But we can also change, and then a column, and then we need to initialize this branch, so define what is a branch, what is a line to Python. We start with a def, so the function, and underscore 2 times underscore, and then init, and then underscore. This is the needed. It is a function that is needed for each object. And what is the arguments of this function? It is mandatory to start with self, because the object needs to know himself. No, the name instantiation. I don't know, bus 1, but in this branch 1, branch 2. No, so the specific line. And then how to classify the line? I think that we can classify by putting the sending node and the receiving node. No? So we can say node k if the line is between bus k, bus m, node k, and node m. In general, the line is classified by the impedance, no? So we can put ZKM, and also by the shunt admittance, YKM shunt. I'm putting the names, so you can change just the names of the variables. And the branch can be a line, but can be also a transformer. So we can also put a transformer ratio that we can call AKM. What I have in mind, probably, I don't want to run, it is only to save. I do apologize. What I have in mind here it is this concept, no? So each branch can be represented. Yeah, it is. I don't know if I have this. You see that each branch, each line can be represented by this elementary admittance matrix that links the currents at both ends of the line and the voltages at the bus. And these are the parameters, the impedance along the line and the shunt admittance in the line. We consider the line balanced here. And so single phase representation. And also the transformer can be represented in a similar way with the ratio of the transformer AKM that we have included. So I will continue here, so having in mind this, and we can say, okay, I storing this information self in the object. So we need to self, so I can say self.k equal to node k. So we can have this information also outside the object, and also self.m equal to node m, and then self.z equal to zkm, and then self dot YKM. The self YKM, I can take the inverse of ZKM. So, because in the admittance matrix, we have the admittances. So, we have this YKM that is the inverse of ZKM. So, I will put 1 divided ZKM. And then we can say also self dot YKM shunt equal to YKM shunt. I do apologize. And then we can also store the transformer ratio AKM equal to AKM. So we are just putting these inputs somehow in the characteristics, in the properties of the object. And then we can also do something more here in the initialization. We can already calculate the admittance matrix. So the elementary admittance matrix is the summation of the two admittances in the diagonal part and minus the admittance between the two nodes in the outside the diagonal. If we need to include also the transformer, we could include the ratio of the transformer square here in this part. So we can start the admittance, it is NP array. So it is a matrix, open parenthesis, close the parenthesis, and then it is a matrix, so we need to put the brackets there. So I can say two brackets open, two brackets closed, and it is two rows. So I will put in this way. So the first row, you see, it is the summation of the admittance. So we can say, if we take into account also the transformer, we can say AKM square. In order to do the square, we need to use these two symbols too. It means that is the square, and then multiplied. Open parenthesis, close the parenthesis, and here we can put our self.ykm that we have calculated here, plus this ykm shunt. And in the second element of the first row, we have a minus AKM if it is a transformer, and then multiplies by self.ykm. Second row, the second row, the first element, it is quite similar, so it is the same as this, so it is a symmetric matrix, and then I need to move, and there is the part that says, I missed a comma here in order to distinguish the elements, and then here the comma is not in this position because it is a square matrix, so we have the final element that is just this one, self ykm plus ykm shunt. So hopefully this is fine. I will try to also to save and to see if there are errors. There was an error saving, and saving changes. I don't know why it is not saving. That can be a problem. Yeah? There is a better Wi-Fi. I see. Without Wi-Fi, it is difficult to do. No.
Anyone having Wi-Fi on mobile, please put it off.
My phone probably. No, it's coming. Oh, thank you so much. Thank you. It is fantastic. So I can, no, error
Again
saving.
it is gone.
So the idea was to create this object of the line and also the nodes, and then try to do a simple calculation for the line. At first, I would like to put just a load, a determination of the line, and calculate the voltage that is needed to provide at the beginning in order to supply the load. Very, very simple. And then we will see, because if there is no connection to internet, it is a little bit difficult. Do you have any question so far? Did you, I mean, it is working a little bit? Yeah? I don't know if you have the same problem as me to connect. Did you save? Perfect, so good. So it was working. So why? Oh, perfect. Thank you. I have also seen that there are people that are also saving and so on. So if you have any question, please stop me. I have just written the elementary matrix. So the elementary matrix for a branch, even in the law, or also a transformer with the ratio. At the beginning, I will just use a line, so for us AKM will be equal to 1. And then I would like to just complete this description. And I would like to complete just saying that all the objects, I would like to have a list of the objects that we implement or instantiate. So if you have a line or 3 lines and so on, at the beginning I will start just for 1 line. So I will put this object in a list. So I create a list branch, and at first I need to initialize. So at the beginning we can say list dot branch, that is just a collection of objects, and at the beginning it is completely empty. And here we can say that this list, I do apologize, I don't want the dot, I want the underscore, I prefer the underscore. And then the name list, I given the list of branches, so branch, and I use a method for the list that is append. So I put a dot and then append, so we can append the new objects. So I append self, because self is the name of our object. Now the object is for me completed. I can also include some other things, and I would like also to include an object that is the bus. So I will do the same. I will save also. We can also run, but there is nothing to see in this file. We have not done nothing than just define the object, but we can see whether there are errors or not. We need to instantiate to create the object. Now we have just defined the object. So apparently it's not complained too much, so we can proceed also with the creation of the second object that we want to include in our calculation, that is the bus. So with the 2 objects probably we can do many things, or not so many. Class bus column. So we can define the object. In order to define the object, we need to start with the def and then underscore init underscore. This is mandatory. So the function init initialization needs to be there. We can also add other methods. What is defined in a bus for me is for sure self needs to know himself, and then I can say the node, which is bus 1, bus 2, bus 3, and so on. We can say the voltage, so Vk. We can put just in per unit, so we can do in the calculation in per unit. We can also say that characterize the bus, also the power. And so we can say the power, and we can put the power in MVA, and also the bus type. In the first case, we can say the sending bus, the receiving bus, or PV bus, PQ bus, or the slack bus in the power flow calculation. So I will close with these columns here, and then I put this data in self. So as in order to can be used this information also outside the objects. So self k, it is equal to node k. For example, I said self just v, the voltage, it is equal to Vk in per unit, and then self s, it is equal to Sk in MVA, but since we have started to use the per unit, we can also put in per unit also the power, so I can divide it by P base, the base power for the per unit system, but in this case we need to define P base before, so before we can take, for example, P base, and we can take, for example, a value that is in accordance of our calculation, for example, 100 or something different. We will see. Then we can also here put this object in a list, so list bus append, so we append the object in self, so in self, and then we can put here some conditions that discriminate the role of the node according to the type, but I will do just after in order to see if this is working. So I would like to instantiate the line and the nodes, so put the problem, and in order to use this list bus here append, I need to initialize this, so I need at the beginning to say that there is this list of objects that is at the beginning empty. I'm trying to save, hopefully saving, and then I would like to instantiate the first idea. So at the beginning I would like to solve this problem. So we have a line, very simple. We have a line, and we have a load here of 125 megawatt, 5 megawatt. Obviously we have the characteristic of this line, and the voltage here is 215 kilovolt, and no, this is P, Q is 0, so power factor is 1. And here the voltage is 1 in per unit, so the rated value of the voltage is in per unit, and we would like to calculate the voltage in the sending bus. So this is sending and this is the receiving bus, and that is very simple. We don't need the objects and so on and so forth. It can be done, this calculation, just with these instructions that you find also in the file. Did I share the file of the presentation? Probably not. I will also share the file. Okay, this is just the simple equation. No? You have the impedance, you can, since you have the voltage and the power, you can calculate the current. So the current is here, you just take into account the current and the impedance, the model, and so you can calculate the voltage drop inside the line, delta V. And of course, the voltage at the sending end, it is equal to the voltage at the receiving end plus delta V. So very stupid things. But we can do something more complicated just to pass. No, because we can enlarge. No, we want to use these objects. No, so I will use these objects here to. Here, and we want to instantiate. Since this is the power, 125, so probably we can use the same value also for the P base, 125. Unfortunately, there are all errors in saving here, so I'm not connected to internet. It is, but I will try. No, now it's working. So I will continue. I would like to instantiate the line. So in instantiate the line, we need to put the parameters of this line. So I will just here write just instantiations, so you know what I'm doing. And then I write instantia. So we put the values, so ZKM, it is equal, the data are 34.167, and for the resistance and the reactance is 183.615 J. These are, and the value ZKM in per unit needs to be taken into account the values, the base values that we have defined before for the power. What we need to take into account also the value, the base value for the voltage, so V base, and I'm taking into account the value of 215 kilovolt. This we don't need this. We need just to put. I do apologize. This is MVA, and this is kilovolt. So we know what is. So the value in per unit, it is ZKM divided the impedance, so the base value of the impedance that I made a mistake here. Thank you so much. Good. It's better, no? The real part and the imaginary part. The J at the end, no? So you see the J here in order to say that this is the reactance, so the imaginary part. Before, probably I can do something more better here to say that Z base, it is equal to V base square, V base square divided by P base. And also we can say that Y base, it is equal to the inverse of Z base. So we have all the, it is equal. The data are 2.216 plus 598.251 J. They are in microsiemens. So since it is microsiemens, I would like to put in Siemens, so it is multiplied by 1 E minus 6. These are, so the value, so these are in Siemens, and therefore y km shunt in per unit are equal to the y km shunt divided y base. At this point, we can also define the load, P load, that is mentioned here, P load, that is mentioned here, that is equal to 125 megawatt. So I put also the indication. We instantiate the line. We can say line, it is a line. I don't know, we can also call line between the bus R and S. R and S. It is a branch, because we call our object branch, and then open the parentheses, and you see that we need to give not a self, because it is LRS already mentioned, but we need to say node K, node M, and then ZKM, YKM shunt, and AKM. So we can start, we can say that the bus is bus 1, between bus 1 and bus 2, so we can also call this line as line between bus 1 and bus 2, and then ZKM in per unit, and then YKM shunt in per unit, because we are doing this in per unit, then 1 as the transformer ratio. It is not a transformer, it is a line. We try to save and we try to run. This time we would like to see something there. There is an error that I cannot see. What is the reason? Pardon me? Bus K is 1, but it says that branch tax no arguments, so I probably did something wrong here. Branch. Branch, probably branch I've written in the same way, no? Yeah. Apparently, yes. A mistake here in was this mistake. I've written ini, but the initialization function for the object is init, so I need to put here you don't see nothing, but I hope that we can see our object if we can see this list. So list branch we can copy and copy here, list branch, you see, oh yes, there is the object. You see that there is an object inside. So if we write L11.k, we know that there is the bus 1, that is the sending bus. And if we write L1.m, oh, there is the second bus. And if we write L1.ye, you remember why here was this admittance matrix, the elementary admittance matrix, and you see that this is the elementary admittance matrix of the object. So we have the object with us at least. And for the branch, but I would like to also to define two nodes, the sending node and the receiving nodes. So I will put also the two other objects. I mean, the object is the same, is the bus, but instantiate the node in the sending node, the receiving node. So we can say NS, that is bus 1, that is a bus, the object that we have already defined, it is bus 1, and we said that the voltage, we need to define the voltage, and the power, and the bus type. So I can say 1, and the voltage is 1 plus 0J, because it is the rated value of the voltage at the end, and then the power. No, I do apologize. We are in sending bus. So I'm taking here just a tentative value of the final solution. And then the power, we don't know the power, so we can just, I cannot skip. We need always to put a value, so I will put 0 plus J0. And then I put the type of the bus for me is the descending bus. And then the N underscore R, hopefully it is the bus, is working, and this time it is different because the bus is bus 2. The value of the voltage this time needs to be kept, so this is the correct value of the voltage at the receiving bus, and also we put here the payload. And you see here that the power is divided by P base. So I put directly P load in megawatt. P load is the active part plus 0J for the reactive power, because the power factor is 0, and then it is the receiving bus. So I hope that we can see these objects, and I try to run. Before running, I also put the number of the buses here as the length of our list of the buses. And we can also print and bus. Try to save and try to run. Hopefully there are no much complaints. It is doing something. Apparently it's doing, but I am not so convinced. So I will just kill the console and try to run again. So we have tried to instantiate our objects, the line and the bus. I would like to see if there are errors. Apparently no. Also the N bus gives 2, that are the nodes. And if we see the list of the buses, again, you see that there are 2 objects. You can also ask me what is the meaning of this kind of key, but I don't know, and it is just an indication of the internal objects. But we can say that N underscore S dot K is bus 1, and node R is bus 2, so probably all the properties are there. So I would like to start to do the calculations. So I will do the calculation in the, we have sometimes, we don't need to calculate the admittance matrix for a single line. but we do. so we calculated the admittance matrix, so we can write the equation, the power flow equation, in the normal form, so by using the... so a calculation of the admittance matrix, you know that Y matrix, you know that this is the matrix that we are dealing with. So the matrix that represent all the network, in our case, just a single line. So these are the equations for the admittance matrix, so then we can write the equation of the power flow in our single line. So these are the equation for the admittance matrix. It is very simple to build the admittance matrix for in this case, because we have already the object, so we need just to combine the elementary admittance matrix of all the lines of the network, in this case just one. So the admittance matrix of the network, it is just a combination, the summation of all the admittance matrix, the elementary admittance matrices of all the lines. So I will just initialize our admittance matrix. So NP dot array, it is a matrix, so I open and close the parentheses, open two square parentheses and close the first line and the second line. We have that we have two buses, bus 1 and bus 2. So the admittance matrix has many rows as the buses and many columns as the buses. So it is a 2 by 2 matrix. I don't know in general how many buses, so I will put, instead of saying this, I will create just a zeros matrix with the same number of buses and bus, both for the columns and both for the rows. So n bus, comma, n bus. I would like also to be sure that since it is 0, it takes as an integer, but sometimes gives an error. Python, when you are dealing with an integer and then you sum up with this, that is complex. So I'm saying at the beginning that is complex. So it is dtype equal complex. And then I'm closing the parentheses. So in this type, I have a matrix that is full of 0, and then just I put a for I, the index, in list branch, because we need to sum up all the elementary admittance matrix of all the branches. And then we can say y, and then we say here ik dot k. What is I dot k? I, it is in the list, so it is the object. The object dot k, so it is the bus. So this bus. But the bus starting from 1. I said bus 1 and bus 2. But in Python, I start from 0. So I need to take into account this. So for Python, the first row of the admittance matrix, the first column of the admittance matrix, it is column 0. It is row 0. And our is bus 1. So I needed to put -1. So I put -1 here. And then the element I dot k -1. So we are dealing with the element in the diagonal. So the element in the diagonal, it is the element, we are doing this iteratively for many lines. Indeed, it is one line only. So I sum up with respect to the previous value. So in general, you put this symbol. Plus equal. What is the meaning of plus equal? It is a little bit strange. It is the same as saying, oh, take the previous value of this quantity and add what there is in the right part of the equal. So it is just this. So plus equal means add to the previous values of this. So it is equal to saying this equal to the same plus the other thing. So I put here plus here. Oh, not equal. Plus here, and then I need to add the element of our admittance, elementary admittance matrix. So y, I, we, y, e. So we have already seen that this is the elementary admittance matrix, the element, the first element of the matrix. So it is the element 0, 0. And then I do this for all the 4 elements of the admittance. So I will do this, 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 and this. This is quite stupid for a single line, but for many lines it is very efficient, because it just keeps the values from the elementary admittance matrix and put in the global admittance matrix for all the networks. So Km It is the element 0, 1, and mk, it is the element 1, 0. You can also print the admittance matrix. Y, and then save and run. I've written badly this branch. This is branch. I do. So this is our admittance matrix. It is good for everybody. I'm just checking if I wrote something bad. But apparently it's fine, no? This is our admittance matrix for the single line. Happy? We have some minutes to do something more. So I will, if there are questions, you can say me. But I would like to start a little bit to write the equations, to solve our difficult problem, not to calculate the voltage at the beginning of the line. So I will just put the so-called set, so some reference, no, the voltage. I would try to put. So I put a V set equal, and at the beginning I put 0. Zeros for the number of buses, and bus. And bus. Again, I would like to put that are complex numbers, so it is 0 but complex. And we do the same also for the power. So we have the collection of the voltages and of the power as set. And then we can now store here the values of the voltages. So for I in list bus, and then column, and then we set V set, yes, V set, I do apologize, V underscore set equal, and then this, oh, excuse, I do apologize. The element should be I dot k, always -1 because Python starts counting from 1, and then IV. IV was the property of the node that we store here in self. This is IV, V in per unit. So we have the voltage stored here, and also we do also the same for the power. Again, IK, I dot k -1, and we can store I dot S, so the power of all the nodes. And then we need to start. This print Y can be put above, just after the Y. And then we need to start to write the equations. I will use the last part of this of the lecture, not to write the equation that we can write also in the next lecture, but I would like to start with distinguish the roles of the buses for us. The role of the buses is when we need to fix something, and when we need to calculate something else. So what are the inputs, what are the outputs? In this problem, you see that you cannot classify the buses as the normal PQ, PV, slack, because in this bus, you fix the active power, the reactive power, and also the voltage. So it is, and here is nothing. No, so we can say that we can fix the things. I will say, saying that this is the receiving bus in which we fix P, Q, and also V, and makes this very simple, the solution of the system. And here in the sending bus, oh, I don't fix nothing. Indeed, here with this V, I'm fixing things. I'm fixing the modulus, but I needed also to fix the reference for the angle. So it is also angle. So it is. This is why it is easy. And so we fix two things, no? So we fix four things. So we need four equations, because for the solution of a problem, we need as many constraints, as many equations as the unknowns. And here we have four unknowns that are the voltage, both in modulus and in phases, but also the power, active and reactive power at the beginning of the line. So we have four unknowns, four equations. We need to set this in the object. So I will go back a little bit to the object of the node and say what is the difference between S and R. Just a minute, and then we are ready. Yes? It's 315. And I'm putting just this indication in the object, and then we will write the equation tomorrow if you like. Or not tomorrow, on Thursday. We will write these four equations here. But I would like just to put this, because I don't know if I will remember this in the bus. So I will put here this information of the sending and receiving here. So I will put here an if. So I'm in the object that is the bus. So you see the class bus, I'm here, and I would like to use here the bus type. So I would like to put if the bus type is sending or receiving. So if bus type is equal, so this is the conditional. If bus type is equal to the receiving, then I put a column, and then I create a list of the receiving bus. So it is we can say index, I need to know the index of the bus R dot append, and I will put here node K, so the node, bus 1, bus 2, we know that Python starts counting from 0, so it is node K minus 1. And then elif, so if it is not R, it is S, or we can also write if bus type say elif, if bus type is equal to S, then we put in a list just for these nodes, that is S node K. This gives an error because this list are not initialized, so it doesn't know this list. So I put here this list as IS, IR, IS, start S, and I underscore SR equal. We can just check whether it is running. If there are errors, we will deal with on Thursday. Apparently there are no errors. Apparently there are no errors in the list of the sending bus. We have bus 0, so the bus 1, and in the list of the receiving bus, I hope that there is one, yes, one that is bus 2. I'm sharing to you this, file, and see you tomorrow. Do you have any questions so far? Good. I don't know if, can you share the thing? Yeah, I don't know. Because it is not my computer, it is, that is sharing it. You can send it to WhatsApp.